Welcome to Math with Professor V. This is video lecture for section 4.2 for business calculus on derivatives of products and quotients. So in the last video, we started learning differentiation rules, how to find derivatives of functions without using the limit definition, thank goodness. And now we're going to expand our tool set so that we can take the derivative of more complicated functions. So the first rule we're going to look at is the product rule. Let's zoom in. So if you're trying to take the derivative with respect to x of a product of two functions, you have f of x and g of x. The rule is as follows. You take the derivative of f prime, and then you multiply it by g, regular g, not the derivative of g. And then you add the product of regular f and g prime. So what I always tell my students is notice it's like they basically take turns having their derivative taken. What do I mean by that? Well, you have f and g, that product. First, it's f's turn. We take his derivative, leave g alone, plus, and then now it's poor little g's turn to have his derivative taken. He was waiting this whole time. The other thing too to remember, this is a product of two functions, product rule. So in between the two terms, P for product, P for plus sign. Okay, this is always going to be plus. So the nice thing about the product rule is that all of the operations that it consists of, namely multiplication and addition, are commutative. So if you switch up the order and you do fg prime plus f prime g, that's fine, right? So you've got a little bit of wiggle room with how you apply the formula. Just as long as you remember, when taking derivatives of a product, everybody has to wait their turn, one function at a time. Okay, next rule, a little bit more tricky because you have to pay attention to the order in which you do things, is for the quotient rule. So here, if we're taking the derivative of a quotient of two functions, so we have f divided by g, the rule is as follows. You take f prime times g left alone minus f times g prime divided by g squared, not g prime, just g. And to help you remember the quotient rule, there's like a little, it's not a song, kind of like a little rhyme that can help you. And I've been saying it in my head for 20 plus years, thanks to my high school calculus teacher who showed it to me. So I'm eternally grateful. I will teach it to you right now. Are you ready? Yes? Okay, wonderful. So the thing is, you have to think of f divided by g as high over low. Numerator over denominator, like the numerator is up top, it's high, denominator is low. Okay, so if we're taking the derivative of high over low, here's the song. Are you ready? It goes low d high minus high d low over low low. I'll recite it a little better right now. I just was writing it. So we've got low, that means the denominator, which is g. D high means derivative of the numerator, that's f prime. Minus high, that means numerator. D low means derivative of the denominator. So whenever there's a d in front of something, we say that means take the derivative of, over low low. I've also heard a remixed version of this where they say square the bottom, away you go. So you just kind of recite it to yourself and it'll become kind of like a little rhyme. So let me add some music notes. Oh my goodness, this is giving me trauma flashbacks to piano lessons. Okay, so low d high minus high d low over low low, or square the bottom, away you go. That's it. I'm going to say it every single time I do the quotient rule to help you. And I think it'll just help you make sure you don't switch up the order. Because notice in the quotient rule, since we have subtraction in the numerator and subtraction's not commutative, if you switch it up and you get the order wrong, then your answer's wrong, sadly. Okay, let's hop to it. Let's practice using these rules. So find the derivatives of the following functions. Now, for the first few, technically we could just sit there and multiply it all out, FOIL it all out like we did for some of the problems in the previous lesson, and then take the derivative term by term and not use the product rule? We could, but the purpose of these exercises right now is just to practice using the product rule. That way you learn it. So we're not starting with like the spiciest examples out there where you absolutely have to use the product rule. We'll get there in a moment. But yes, there is another way to differentiate the first few functions. We're just building our skill set, okay? Here we go. Why don't we label the functions just to help you out? This is f, and this is g. Okay, so we're trying to find dy dx, and I'll just write the product rule again up here. It's f prime g plus fg prime. They take turns. So here we go. Dy dx equals f prime, derivative of f of x would be 10x. That's it, because derivative of minus 1 is 0. That's f prime. Then I multiplied by g left alone. Don't touch it. Don't do a thing. Times 4x plus 3. It's product rule, so what comes next? A plus sign. Plus for product rule. And then you have f, leave it alone. No derivative. 5x squared minus 1 times, now we multiply by g prime. Derivative of g is 4. Very good. Okay, how we doing? Now, from here, we don't leave our answer like this. We're going to distribute everything and then combine like terms if possible. So let's see here. This is going to give me 40x squared plus 30x plus 20x squared minus 4. And then combining like terms, I have a total of 60x squared plus 30x minus 4. And that is it. Good? Okay, very nice. Let's look at another example. We'll just keep practicing till you guys feel professional. Again, let me label. This is f of x, and this is g. And remember, anytime you see square root of x, think of it as x to the 1/2 power. That way you can take the derivative using the power rule that we learned in the previous lesson. So here we go. Dy dx equals f prime, so derivative of 2x minus 3 is 2. Good. So right now it's f's turn to have his derivative taken. It's not g's turn. So we're just going to leave g alone. It's x to the 1/2 minus 1. Leave it alone. Plus, now f already had his turn, so you stay put f. You're just 2x minus 3. Now it's finally g's turn to have his derivative taken. So square root of x minus 1, derivative of x to the 1/2 is 1/2 x to the negative 1/2. And then derivative of minus 1 is 0. How are you doing up to here? Okay, the calculus is done at this point. So now we just have to clean it up. Now it's just a matter of how good are your algebra skills. Ooh, that could be questionable. Okay, so we're going to distribute. Same thing here, okay? So we're going to have 2x to the 1/2 minus 2 plus, be careful here. This is x to the first, 2x, times 1/2 x to the negative 1/2. The 2 and the 1/2 will cancel. Then I'm going to add the exponents. 1 and negative 1/2 gives me positive 1/2. So I have 1x to the positive 1/2. I'll say that again. This is x to the first. So when I'm multiplying 2x to the first and 1/2 x to the negative 1/2, I add these exponents. 1 minus 1/2 gives me positive 1/2. And then distributing the last term, now I get minus 3/2 x to the negative 1/2. Don't write 1.5. Nobody wants your decimals unless the directions in the problem say use decimals, okay? Or if the problem starts off with decimals, then that's your cue. Ooh, decimals are okay right now. Otherwise, always just use a fully reduced fraction. Okay, can we combine any like terms? Yes, notice 2x to the 1/2 and x to the 1/2, those are like terms. So I can add those together, just the coefficient, don't touch the exponent. So it'll be 3x to the 1/2 Then let me put next my variable, my term with the variable, minus 3/2 x to the negative 1/2 minus 2. Now this is a nice way to leave your answer just in case you're going to take another derivative, like a second derivative, which we haven't done yet, but that's coming up. Or sometimes your instructor might want you to go back and write your final answer using radicals, no negative exponents. So if that's the case, then you should write 3 rad x minus 3. I'm going to put that x to the negative 1/2 in the denominator. So now it's rad x in the bottom. And then this 2 just goes and joins it because it's already in the denominator, minus 2. So that's your other option. And again, just check with your instructor, see if they care how you write your final answer. Okay? Good. Example C, we have q of x equals x to the negative 1/2. No, x to the negative 2 minus x to the negative 3rd times 3x to the negative 1st plus 4x to the negative 4th. So what I think you should do is pause the video and see if you can try this one on your own. And if you're like, that's not happening, I'm not ready for such things, that's fine. I'll solve it in just a moment, but see, push yourself a little bit. Okay, here we go. So this is F, this is G. And I'm noticing like the problem already started off with negative exponents. So I'm going to take that as my cue that it's cool to leave negative exponents in my final answer. If they weren't okay with that, they shouldn't have started things off on this foot. So I'm just putting it on them. So q prime of x equals. Be careful with the negative exponents, right? So first let's take the derivative of f. Derivative of x to the negative 2nd is going to be negative 2x to the negative 3rd. Good. Then bring down the negative 3 in front here. This is going to become positive 3x to the negative 4th. That's f prime. This is f prime. Times g, leave g alone, 3x to the negative 1st plus 4x to the negative 4th. F prime g. Plus, then we leave f alone, x to the negative 2nd minus x to the negative 3rd. So this is f. And then now I need g prime. So can you compute g prime? Bring the negative 1 down front. This is going to be negative 3x to the negative 2nd minus 16x to the negative 5th. How are we doing? Did you guys get it okay up to here? Very good. Now I'm just going to start distributing everything. So we're going to have ourselves a little FOIL party. Okay, this is going to be negative 6. Add the exponents, x to the negative 4th. Then this is going to give us negative 8x to the negative 7th. Add those exponents. Then I'm going to come in here. This is 9x to the negative 5th, positive. And then last we have 12x to the negative 8th. Very good. Plus, okay, I'm just going to do the arrows in my head so it doesn't get too messy looking. Minus 3x to the negative 4th, and then minus 16x to the negative 7th. Inner product is 3x to the negative 5th plus 16x to the negative 8. What a mess. Okay, from here, let's just check. Can I combine any like terms for my final answer? I'm thinking yes. So let's see. X to the negative 4th is the highest power, right? It's the least negative. I'm going to put everything in descending powers. Ooh, and then there's negative 3x to the negative 4th. So altogether, that's negative 9x to the negative 4th. What's next? X to the negative 5th. So I have 9 plus 3, so altogether 12, x to the negative 5th. And then next would be negative 7. So negative 8 and negative 16. So that gives me negative 24, x to the negative 7th. And then lastly, 12x to the negative 8th, 16x to the negative 8th. That's 28x x to the negative 8th. Boom. Just box it so that you're really confident in your final answer. Okay, so those are the product rule applications. If you feel like you need more, I do have other videos practicing the product rule for the regular, not business calculus 1 video lectures. I'll link a couple of them in the description. If you see any trig functions like sine, cosine, tangent, examples with those, skip them. But otherwise, they'll apply to you just fine. Okay, we need to practice the quotient rule. Are you ready? I love the quotient rule. High over low. So remember, it's low D high minus high D low. Square the bottom. Away you go. All right. Enough of that. So low means write the denominator, don't change it. D high means derivative of the numerator. What's the derivative of 8x minus 11? Very good, it's 8. Minus high, so just the numerator, don't touch it. D low, what's the derivative of the denominator? Yes, 7, good. Over low, low. So square the denominator, just write 7x plus 3 squared. Don't actually sit there and multiply it all out. I've said this before, I'll say it again. 99% of the time in math, you don't want to actually multiply out or FOIL your denominator, okay? Just the numerators. All right, so let's clean up now. Just distribute and then see if you can combine some like terms. So what is this going to be? 56x plus 24 minus 56x, watch this, plus 77. Did you get the plus? Oh, good. Well done. Over 7x plus 3 squared. And then are you noticing anything we can simplify? Exactly. 56x cancels out. Then I just have 24 plus 77. So that's going to be 101 over 7x plus 3 squared. Okay, beautiful. How do you feel? Just practice it. It'll become second nature sooner than you think. Honestly, every time we go over the product rule, quotient rule in calc, the students are a little taken aback at first, and then you'll be surprised how quickly you'll just learn it and it'll become no big deal. Okay, this is the painful part. It'll flow in a minute. Okay, let's try another one. Example E. Negative x squared plus 8x over 4x squared minus 5. So high over low. So dy dx equals low means leave the denominator alone. 4x squared minus 5. D high means multiply by the derivative of the numerator. What's the derivative of the numerator? Good. Negative 2x plus 8. Perfect. Minus high, so leave the numerator alone, negative x squared plus 8x. D low, derivative of the bottom would be 8x. Perfect. And then low, low. So square the denominator. 4x squared minus 5 squared. All right. Now the calculus is done. It's just a matter of cleaning everything up. So we're going to just start foiling our little hearts out in the numerator. So we're going to have, hold on, that was crooked. I'm not pleased. There. So just foil here, here. Okay, that'll give us, where's my light blue? I keep losing it. Negative 8x cubed plus 32x squared plus 10x minus 40. And then distribute the last two terms, also distribute the negative. So we'll have plus 8x cubed minus 64x squared over 4x squared minus 5 squared. Perfect. Anything you notice we can clean up? Yes, 8x cubed is out of there. And then I can combine some like terms, right? Because 32x squared, negative 64x squared. Let's put everything in descending powers in the numerator. So I'm going to have negative 32x squared plus 10x minus 40 over 4x squared minus 5 squared. Fabulous. Very good. Okay, we're going to spice things up a little bit, throw in a square root. You guys can handle it though. I would say before you even start taking the derivative, rewrite this. This is t to the 1/2 over 2t plus 3. Okay, so here we go. R prime of t equals low, so denominator, don't touch it, just write 2t plus 3. D high is derivative of the numerator, so 1/2 t to the negative 1/2. Minus high, so the numerator, leave it alone. D low, derivative of the denominator is 2 over low, 2t plus 3 squared. Very good. Let's distribute 1/2 t to the negative 1/2. Remember, this is 2t to the first. So the 2 and the 1/2 will cancel, and then I'm going to add 1 and negative 1/2 to get the new exponent. So I'm going to end up with t to the positive 1/2 plus 3/2 t to the negative 1/2 minus 2t to the 1/2 over 2t plus 3 squared. Good. You guys okay? Now I can combine, these are like terms. T to the 1/2 minus 2t to the 1/2. That's going to give me negative t to the 1/2 plus, and then I want you to notice something. Anytime you have negative exponents in a fraction, you should rewrite them in the denominator. So I'm going to write this as 3 over 2t to the 1/2. And then the denominator is still 2t plus 3 squared. So why should we do that? Because now I can clearly see this is something called a complex fraction. When you have a fraction inside of a bigger fraction. And that's a big no-no in math. It's not considered simplified. So to fix this issue, what we need to do is multiply everybody by what we don't want. We don't want this 2t to the 1/2 here. So that's the LCD. I'm trying to get rid of it. Everybody's going to get multiplied by 2t to the 1/2, top and bottom. So I'm going to distribute that across, okay? Notice here, 2t to the 1/2 times negative t to the 1/2. I'm going to have 2 times negative 1, and then add those exponents. 1/2 plus 1/2 is 1. So this will be negative 2t to the first. You don't have to write the 1, but I'm just letting you know where it came from. 1/2 plus 1/2. Plus, and then here's the cool part, this just cancels out completely with the denominator we don't want, and you just have a 3 now up here. Hooray! And then you still have 2t plus 3 squared, 2t to the 1/2. Usually if you have one term by itself, this little monomial, well, no, it's not a polynomial, just one term, put it all the way in the front. It looks strange to have it at the end like that. So 2t times 2t to the 1/2, excuse me, I got too excited, times 2t plus 3 squared. And then I would say, for aesthetic purposes, I would write the numerator as 3 minus 2t. You don't have to. It wouldn't be marked wrong, but it just looks so much better not to have that negative sticking out in the front. Okay, there's our final answer. Okay, beautiful. Are you ready for the semi-grand finale? Okay, so last example for these kind, we have a couple more after this. We have g of x equals 2x squared plus 3 times 5x plus 2 over 6x minus 7. So notice we're going to have to do the quotient rule, but we'll also have to do the product rule when taking the derivative of the numerator. Now, if you're like, this just sounds like a disaster waiting to happen, then what you could do is you could just FOIL out the numerator and then only worry about doing the quotient rule. That's totally appropriate. So I'm going to leave it up to you. I would say it's safer to do it that way, but if you just want to practice doing multiple rules at once, let's just go for it. Okay? So here we go. G prime of x equals, low means denominator, D high means we need the derivative of the numerator. So here we're going to have to do product rule. There's F, there's G. So we're going to need F prime times G plus G prime times F. This is low. This is D high. F prime is 4x, very good, times G, leave it alone, 5x plus 2, plus G prime, derivative of the numerator of 5x plus 2 is 5, and then times F, leave it alone, 2x squared plus 3. I think earlier I wrote FG prime. It doesn't matter. Multiplication's commutative. Okay, so here's low, D high. Minus high, so the numerator, as is, don't touch a thing. And then D low, derivative of 6x minus 7, 6. Very good. Over low, low. Okay, now you just got to multiply everything out. So let's see. We have 6x minus 7 times, inside if I distribute this is going to be 20x squared plus 8x plus 10x squared plus 15 minus, let's FOIL these two first and then we can run the 6 through in a minute. So this is going to be 10x cubed plus 4x squared plus 15x plus 6 times another 6. Over 6x minus 7 squared. Okay, good. Now, before I FOIL all this out, I'm noticing I have some like terms I can combine, so definitely take care of that because then you'll have less things to multiply. So this is going to be, let me just rewrite these two parts here so we don't have to rewrite the whole problem. This is 30x squared plus 8x plus 15. That's what I'm going to multiply by 6x minus 7. Here we go. That'll be 180 x cubed plus 48 x squared plus 6x times 15, that's 90x. And then now I'm going to distribute the negative 7 through. So that's minus 210 x squared minus 56x minus 105. Good? Okay. And then all that's left is to distribute the 6, and I'll also distribute this minus sign simultaneously. So minus 60x cubed minus 24x squared minus 90x minus 36. And this is all over 6x minus 7 squared. Whew, okay, now combine like terms. So let's see, call in the cleanup crew. Highest power of x I see is cubed. So we've got 180x cubed minus 60x cubed, so that's 120x cubed. Now let's go to the squareds. 48 minus 210 minus 24, that's negative 186x squared. Is that everybody? Yeah. Then x to the first, so 90 minus 56 minus 90. Oh, that's easy. Those cancel, so I just have minus 56x. And then constants, negative 105 minus 36, negative 141 over 6x minus 7 squared. Okay, how was that? That one was just tricky because there were so many steps, and it's easy to just make a careless little mistake and then it derails the whole problem. So if you messed up somewhere, don't get upset with yourself. Just practice again, see if you can get it right on your own. Then you know you're really in business. Okay, last couple examples have to do with applying the product rule and quotient rule, but you're not actually given the equation of the function. These are super fun, I think, because they're a little less tedious. It just checks if you know the rule. So if g of 3 is 4, g prime of 3 is 5, f of 3 is 9, and f prime of 3 is 8, find h prime of 3, where h of x equals f of x times g of x. So don't get freaked out with all this info they give you. We're going to use it at the end. First, just focus on what's happening. They want us to find h prime of 3, and they told me h of x is the product of these two functions, f of x and g of x. So first things first, let's find h prime of x. Let's find the formula or the rule for h prime of x. And then I'll go back and see what did they give me all that info for. So since h is the product of two functions, when I find its derivative, I'm going to apply the product rule. So h prime of x equals f prime of x times g of x plus f of x times g prime of x. We literally just rewrote the product rule. Okay, then they're asking me to find h prime of 3. So you're literally just going to come through and substitute in 3 for all the x's. So h prime of 3 would be f prime of 3 times g of 3 plus f of 3 times g prime of 3. Good. Now, oh, it makes sense why they gave us all this info. F prime of 3, they told me that's equal to 8. So you're just going to replace that with 8. Then what about g of 3? Did they tell me that? Yes, it's 4. Plus, keep going. I don't want it to get too crazy with the colors. F of 3 is 9. And then g prime of 3, 5. So it all works out in the end. Don't stress too much. Like, what are all these constants? 8 times 4, that's 32, plus 45, 77. Okay, one more like this. Find b prime of 3, where b of x equals f of x over g of x. So first, find b prime of x. Then you're going to substitute in 3 for x. So we have low d high is f prime of x minus high d low is g prime of x over low, square the bottom, g of x squared. Good. Now replace all the x's with 3's. So b prime of 3 equals g of 3 f prime of 3 minus f of 3 g prime of 3 over g of 3 squared. And they gave me all that info up top. So g of 3, that's 4. F prime of 3, 8, very good. Minus f of 3 is 9. G prime of 3, 5 over g of 3, which is 4 squared. So what is this going to be? 32 minus 45 over 16. So that's negative 13 over 16. And leave it like that. Remember, don't bust out that calculator and start giving decimals unless it says to in the directions. So that concludes the lesson. I hope you found it helpful. And like I said, don't worry. In the beginning, the product rule, quotient rule can be kind of overwhelming. And then once you've practiced a few homework exercises on your own, you'll get the hang of it. And in a few days, a week tops, you won't even realize you're thinking it through. It'll become more second nature. So that concludes the video. Don't forget to give it a thumbs up, subscribe if you haven't already. If you need more help in other math classes, then check out the rest of the videos on my YouTube channel organized into playlists. Please follow me on Instagram, TikTok, Twitter, Math with Professor V. Thank you guys so much for your support. I'll be back sooner than later. Bye.